the recordings. But no problem. If you get it, probably they are busy at their place of work and all right, let's just begin with today's topic. Differentiation. In mathematics, differentiation is a fundamental concept in calculus that deals with studying rate of change and slope of curve. That is a differentiation. You can also call it to differentiate a function. To differentiate a function is also finding a derivative of the function. That is, differentiation is the process of finding the derivative of a function, which represents the rate of change of the function with respect to one of its variable. All right, I want to share some things with us on the screen. Oh, you can hear me loud and clear. Hello?
I can hear you.
All right, thanks very much. So, now, okay, let's have this. No, no. All right, differentiation in mathematics. Differentiation is a fundamental concept in calculus that deals with studying rates of change and slopes of curves. You can write it down. You can write it down. You can also have differentiation in mathematics. Differentiation is the process of finding the derivative of a function which represents the rate of change. Everything is rate of change, rate of change, rate of change with respect to one of its variable. So this is delta symbol. When you see dy dx, this one is like capital dy, capital D, dy dx. This one is like the small letter. Please, are you seeing my screen? Hello?
Yes, you
Okay,
can see it. You can see it.
thank you very much. So they are called delta. Those that are from delta states. They have gotten your namesake here. They are called delta. So delta represents change or increment in a variable. Different quotient, that is, approximate the derivatives and small change or infinite now. Now, I want you to know something. I'm just introducing this topic to us. Yes. So, I want us to start by showing my board with full explanation. All right. Please, can you see the board? Is the board showing? Hello?
Yes, we can see the whiteboard.
Okay. Okay. Let's have this. Differentiation. Differentiation. Also known as derivatives. 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 That is where you see dy dx. That is dy dx. Please, can you see my screen? I mean, can you see the board clearly? So can we move on?
Yes, we can see the board clearly.
Okay, thank you very much. Now, I want us to start with derivative of a constant. Derivative of a constant. Let me do like this. Derivative of a constant. Derivative of a constant. Now, what do I mean by derivative of a constant? Let's have a function like this. Let's have a function. Let's have something like 2x squared plus 5x plus 7. This is a function now. Let's call it f of x. This is the function 2x squared plus 5x plus 7. Now, the constant in this function is this 7. This 7 is the constant. That 7 is the constant. Let's have something like this. 3x cubed plus 4x squared minus 10. Because this 10 is not attached to any variable. This 7 is not attached to any variable. That is, they are not coefficient of x or y. So they are called the constants. Do you understand that? So this minus 10 is a constant. This 7 is also a constant. Please, do you understand that? Hello?
Yes,
Are we together?
yes, we understand.
Okay. Now, let's now find the derivative of a constant. Derivative of any constant is 0. Saying derivative, you can write it down. Derivative of any constant is 0. Derivative of any constant is 0. That is, now let's find the derivative of this 7 now. That will be find the dy. If you want to find derivative, you mean find dy dx of this 7. So let me have it like this. So let's have something like this. If you have to find derivative, you mean this is dy dx. That is derivative. So find dy dx of this 7. That is, find dy dx of this 7. That simply means we want to find the derivative of this 7. 7. And I said derivative of any constant is what? Are we together, please? Huh?
0,
Zero,
0.
zero.
So derivative of any constant is 0. So derivative of this 10 now, dy dx of minus 10 is what?
0.
Please, I want you to respond so I will know that we are
Zero.
together. Thank you very much. 0. So derivative dy dx of any constant is 0. Please note that derivative of any constant is 0. So if I have something like this, x squared plus x plus 4. What is the derivative of this 4?
Is 0.
Thank you.
Zero.
dy dx of that 4 is 0. Thank God we have known that. So let's move on. Can I rub the board? And we start with power rule. Differentiation using power rule. Can I rub the board?
Yes, sir.
Okay.
Yes, sir.
Okay. So derivative of any constant is 0. Good. Now, let's start with power rule, the power rule. Please, I want you to take note of this very well, because it's the foundation of this differentiation when you are solving dy dx. Now, if you want to start with power rule now, dy dx over x raised to power n. Now, this is how we do differentiation. This is how we find derivative. This is how we differentiate. Now, we use times and take, or take and times. That is I want you to have it as shortcut, like take from from the word subtract, then this times from the word multiplication, multiply. Do you understand that? Now, to differentiate this function x raised to power n, once you see dy dx, they are automatically telling you that differentiate or find the derivative. That is the reason why it's called dy dx. Now, if you are to differentiate this x raised to power n, differentiate x raised to power n, you are to subtract 1 from the exponent. Do you understand that? Subtract 1 from the exponent and multiply it with the function. Now, this is what I'm saying. It is times and take. Subtract 1 from the exponent, we multiply with the function. Now, what first thing I'm going to do, please don't forget, times and take, times and take, times, take, times and take. Do you get that? So, this is the exponent. The power that this function is raised to is the exponent. Now, let's multiply with this. Let's multiply with this function. This n, let's multiply with x. What will it give us? That is, we want to multiply x multiplied by n now. I mean, n multiplied by x. It will give us what? nx. Eh? Are we together, please?
Yes, sir.
Yes, sir.
Yes, we are
n
together.
multiplied by x will give us nx. Then times and take. Now you are going to take 1 from that exponent, or subtract 1 from that exponent. That's the second step to how to differentiate. That's the second step. Now let's take 1 from this exponent, which is n. That will be n minus 1. Do you understand this now?
Yes, sir.
Now, we are differentiating x raised to power n. It's very simple. Differentiate or find the derivative of x raised to power n. First of all, multiply this exponent with the function. That will give us xn. That is 10 times. Then, secondly, subtract 1 from the exponent. That will give us xn minus 1. So let's now introduce this method in differentiating something like x raised to power 2. So, find the dy dx of x raised to power 2. We have started differentiation. Let me say this is example 1. This is example 2. Example 1, example 2. Let's differentiate this term. To differentiate this term, it will now be, you multiply this 2 with this x. It will give us 2x. Now, from these
Raised
two,
to the power of 4.
from these two, you have to subtract what? 1.
1.
2 minus 1. So automatically it will
I
give
have to
us what?
subtract 1.
It will give us 2x raised to power
2s.
1, which is still 2x. So we have differentiated x raised to power 2. Our final answer is 2x. Are we together?
Okay.
Now let's differentiate. Let's example 3 now.
Yes, sir.
Example 3 now. Find the derivative or differentiate, that's dy dx, with respect to x. Let's have x raised to power 3. X raised to power 3.
Power of 2. That's 3s.
So the first thing you are going to do, multiply the exponent.
3s squared.
Okay? Multiply the exponent with the function, with the term here. That is 3x. That is 3 times x. That will give us 3x. Then you are going to subtract 1 from the exponent. That's why we call it times and take. Subtract 1 from the exponent. That will be, the exponent is 3 that from the power minus 1. That will give us 3x raised to power 2. We have successfully differentiated this term now. That is the method we use in differentiation. As simple as that. Do we understand that?
Yes, sir.
Very, very well, sir.
Okay. Now, this we are using power rule. Power rule. P-O-W-E-R. Power rule. This is how to differentiate. That is how to find dy dx. Just tt times and take. Differentiation times and. Let's have another example. Example 4 now. Find the derivative. I'm not writing the question because if I should write the question on the board now, there won't be enough space for us to do the workings. So find the derivatives or differentiate x raised to power 10. Let's differentiate x raised to power 10. That is, we are going to multiply this 10 with x, which will give us
10x.
10x.
Raised to the power of 9.
Then we are going to subtract 1 from the power, from the exponent. That will be 10 minus 1, which will eventually give us 10x raised to power 9. Do we understand this?
Yes, sir.
Okay. Now let's have another example.
Yes, sir.
Thank you very much. Let's have another example. Let's have something like okay. Let me try to manage. Let me use this. Let me use this part. Let me use that part. Okay. Let's differentiate 4x raised to power 5. That is differentiate dy dx with respect to x. 4x raised to power 5. Find the derivative. All we are doing, we are differentiating with respect to x. We are differentiating with respect to x. We are differentiating with respect to x. Now, we have been differentiating functions or variables without coefficients. Now, if you check this example 5 now, it has coefficients, and the coefficient is 4. Please, are we together?
Yes, sir.
Yes, sir.
Okay. Now, all we have to do here is that, don't forget, we also have coefficient here. They are 1. That is, we have coefficient of 1 here, but it is invisible. So 2 times 1x or 2 times x still give us 2x. So 3 times 1x or 3 times x still give us 3x. 10 times 1x or 10 times x still give us 10x. Now here, we are going to multiply 5 times 4. 5, multiply the coefficient with the exponent. Multiply the coefficient. Multiply the coefficient. This is the coefficient. Multiply the coefficient with the exponent. This is the exponent. Multiply the coefficient with the exponent. Multiply the coefficient with the exponent. This is the coefficient. This is the exponent. So we are still following the rules of times and take, TT. Now, let's now multiply this coefficient with the exponent. It will give us what? That will be 5 times 4 or 4 times 5.
20.
That of the 2.
20x.
20.
It will give us 20x, okay? 20x. We have done the first T. You know we are dealing with TT, times and take. We are dealing with TT. Now, this is 20x now. The next step is we are going to subtract. This is the times. We have done the times now, multiplication. 4 times 5 or 5 times 4, it has given us 20x. Now, we are going to take now. Take what? Subtract 1 from the exponents. And what is the exponent? The exponent is 5 minus 1.
1. It's 5.
It will give us what? 20x raised to power 4. So we have successfully differentiated 4x raised to power 5. This is the final answer. Do we understand that?
Yes, sir.
Yes,
Okay.
sir.
Let's have another example on this differentiation. That is all about dy dx. Dy dx, differentiating a function. Let's have another example here at distant parts because of the people that they may be joining us lately. All right, let's have example 6 here. Please, if you cannot see, if you can't see it, let me know so that I will force to clean the board. Let's differentiate. Find dy dx. Okay, let me even find dy dx. Find dy dx of 6x raised to power 8. 6x raised to power 8. Differentiate this. We are going to use the times and take. We are going to multiply.
One side is 40.
We are going to multiply.
Raised to the power of
Power of what?
7.
Correct. So you are going to multiply this and this coefficient with the exponents, which will give us 48. That is 6 times 8. 48x. We are going to subtract 1 from this 8. Subtract 1 from 8. It will give us what? 7.
7.
So that's the final answer. Please let's write it down. We move on. We move on straight to derivative of a polynomial function. Derivative of a polynomial function. Let's write this down. Derivative of a polynomial function. Derivative of a polynomial function. So, please, if you don't understand it, let me know. We are here to learn. That is why you are here. I decided not to make this class a general class. Just especially for those that they are ready to learn and they are focused. It's not by multitude, but by seriousness. Though some people are supposed to be in this class, but they are not available due to network stuff or the place of they are busy or whatever. So they are not included. Others that they know there's a class now and they are not really paying attention. They will not be rushing Mr. Ben the day before the exam. Tell me how they'll be able to catch up all this a day before exam. Would that be possible? Nope. All right, let me know if you are done with this so I can rub the board and we move on. That is how to differentiate. That is how to find derivative. So derivative is also differentiation. Derivative is also differentiation. Then you are differentiating, then you are finding the derivative. If you are done, let me know so that I can rub the board. I'll continue with. Let me know if you are done, please. Please, are we done? I can't hear any response. So, am I still connected with you, my people? I'm just
Yeah,
Yes, sir.
yes, sir. We are
okay.
done, sir.
All right.
Yes, we are done.
Okay, thank you very much. All right.
Please, sir, I have a little question for clarification, sir. Please, I have a question, sir.
Hello, what's your question? Hello, sir.
Yes, I can hear you, sir. Sir, you say the coefficients of any constant number is 0. Then
Yes, sir. I did not
I
say
just
any
want to
constant
clarify
number.
something about
I did not say
the
any constant number. I said derivative of any constant is 0. I did not add number.
given constant
Okay.
is the act of the one. Is the one constant number that we can use anytime.
Eh?
So I just want to make a clarification about the one,
The one.
the number one you are using. Yes, the one.
Example one. Are you referring to example one?
Yes, the constant one, as in
Okay.
n minus 1, 2 minus 1. So I'm just
Okay.
want to be sure of the one. Is the one constant?
Yes, okay. That one is constant. When you are differentiating, you must subtract one.
Okay.
Yeah, I got your question correctly now. That one is constant. You can't subtract 2. You can't subtract 3. You can't subtract 4. You must subtract 1 when you are differentiating. And when you are integrating, when you get to integration, you must add 1. But here, we are differentiating derivative. You have to subtract 1.
Okay.
So, thank you very much for that. So, let me just,
Okay.
let me rub the board. Let's move straight to, we are just done with power rule, right? Let's now move to derivative of a polynomial function. Derivative of a polynomial function. And we are differentiating with respect to x. That is, we are differentiating with respect to x. All we have been doing, we have been differentiating with respect to x. So let's continue by differentiating polynomial function. Let's continue by differentiating polynomial function. Okay. Now, I've already taught us what polynomial function means when we were doing functions and limit of a function. So let me write it on the board. Derivative differentiating, let me write it like this. Differentiating a polynomial function. Differentiating a polynomial function. Let's have a polynomial function on the board. Let's have something like this. When you have f of x, you know we are dealing with this function. So f of x is, let's have 4x raised to power 3 plus 7x raised to power 2 minus 9x plus 3. Or let me say plus 3 or plus 5 or plus anything. This is 4x raised to power 3 plus 7x raised to power 2 minus 9x plus 3. So let's find the derivative. Find the derivative. This is the function. Now, if we want to find the derivative, this is how you can see like this. F prime x. It also means derivative of this function. It means derivative of this function. This is the function. F of x is the function. The derivative of f of x is f prime x. That is the derivative of the function. This is what I'm saying. Now let's take this out. The function we are dealing with here is the f of x is equal to 7. I'm referring to this. The f of x is equal to 7. Now the derivative of 7 is what?
0.
Is 0. That is what it means. F prime x. Now let me give another example. The function we are differentiating here is 4x raised to power 5. So the f of x we are dealing with is 4x raised to power 5. The derivative of that 4x raised to power 5 is what? The derivative of 4x raised to power 5 is what? When we differentiated the differentiation of
Is 4.
20x
raised to power 4.
Yes.
20x raised to power 4.
20x raised to power 4. Thank you. 20x raised to power 4. So that is it. So the function is 4x raised to power 5. The derivative that we have differentiated of this function is 20x raised to power 4. Now we are given a polynomial function here. You want to find the derivative. That is, you can see something like this. This is the question. You get it now. So if you see something like this, or you can also see it like this, dy dx. Or you can see it like this. Find the dy dx of this function. Whichever way it comes up, or whichever way you come across it, they are only asking you to differentiate this function. So if you see f prime s, that is, they mean the derivative of this function. This is also a derivative. Differentiation and derivative, it means the same thing. Differentiation and the derivative, they mean the same thing. You understand that? So
Yes,
can I continue?
Yes, sir.
All right. So if you are differentiating
Yes, sir.
polynomial function, let me say, if you are differentiating a polynomial function now, I want to find the derivative of this polynomial function. All you have to do is you are to differentiate each term separately. Differentiating each term. Let's start by differentiating this term. It will give us what? 4 times 3.
Raised to power 3
Give us 12 x raised to power. This 3 minus 1. Give us 2. Then let's differentiate this part. Plus, let's differentiate this part now. Times
raised to
the
power of 1.
That'll be 2 times 7. Will give us 14x.
What?
2 times 7 give us 14x. Then this subtract 1 from this 2 to give us 1. So you don't need to write 1. You can just leave it like that. Now, if you have 9x like this, if you want to differentiate something like 9x. The derivative is ordinary 9.
9.
Let me give you the example. Differentiate, find dy dx of 10x. The answer is 10. If you are to differentiate 121x, the answer is what? 121. It has working, so, but that is just a shortcut. I don't want to disturb us. If you are to differentiate, find the dy dx of minus 5 minus 5x. The answer is minus 5. Differentiate. Aha. The answer is minus 5. Do you understand that now? If I have to differentiate, find dy dx of minus 32x. The answer is minus 32. Do we get that?
Yes, sir. So, sir, I have a question, sir.
Okay, what's your question?
Yeah, my question is that maybe if you are writing exams and you have been asked to differentiate 7x raised to power 2 and you differentiate it and the answer is 14x raised to power 1. If you write the one, are you wrong or you're correct?
You don't need to
Since
write one.
you say we can leave it. Okay.
You don't need to write the one. And this is exam. There's no way you can even write that one.
Okay.
So they can't put that one. That one is invisible.
Okay.
Yes, so. So can you continue?
Yes, sir.
All right. Let's continue by differentiating with respect to x. And we are differentiating polynomial function. Yes. We are differentiating polynomial function. Okay. Now, to differentiate minus 9x now, we give us what?
9.
Minus 9, don't forget. Now, we want to differentiate these parts. You give us what? What we did, the first thing we did in this class today. Mute your mic, oh. Please mute your mic. Aliu Joseph, why are you disturbing us? Mute your mic. Now, how are you going to differentiate 3? You should know that 3 is the constant in this polynomial function. And differentiation of 3 or derivative of any constant is what? 0. So it's going to be
0.
Thank you. It's going to be 0. So let me just let me introduce something to us. Have you already written this? Write it down. Divide the x of 10x is 10. Divide the x of 120x is 121. Divide the x of minus 5x is minus 5. Divide the x of minus 32x is minus 32. Please let's write it down. I want us to continue with this. When you are done, let me know, please. I don't want us to miss any parts.
Hello, sir.
Okay, I'm with you.
Yeah, that 4x raised to power, is it raised to power 3 or is it raised to power 2?
4x
question
raised power
itself.
4x raised power 3.
Okay.
3 to the third power.
Okay.
Please, if you are done, let me know so that you can just continue. I want us to do something there. This is how to differentiate. Okay, are we done with that so that we can continue? I just want to introduce something to us here.
Yes, sir. We are done, sir.
Okay. All right. Let me rub this part. We are in mathematics class, and this is university mathematics. So let's teach ourselves in advance. Now, we can call this the first derivative. This is the function we are given. Don't forget. We have differentiated it now, and we have gotten this. Yes or no? Yes. So this is the first derivative. First derivative. If we are, let me write it properly. F prime x is equal to. If we are to find the second derivative, we are to differentiate this again. This is the original function we are given. We have differentiated it. We have gotten this. Now find the second derivative. It will now be f prime prime x. That is second derivative. F prime, first derivative, f prime x. Second derivative, f prime prime x. Let's find the second derivative. So if we are to find second derivative, we are going to differentiate this thing. These are the first derivative again. We have done the function we are given. We have differentiated it. We have gotten this. Then let's differentiate this that we have gotten to get another differentiation, another function. So let's differentiate it now. So 2 times 12 will give us 24. X. Subtract 1 from these two, it will give us 1. So plus, don't forget, if you are differentiating 14x, the differentiation is 14. Differentiation of any constant is what? 0.
0.
So all these 0 may not be necessary. So this is the second
That
derivative.
means
This is the second derivatives. Okay, what's your question?
and like in this case where you were saying plus 14x, that the derivative of that 14x is equal to 14. Can
Yeah.
we also say like the coefficient of x is 14,
The
or
what?
the number attached to it? The coefficient of x.
And the question of x is 14.
Yes, sir.
Yes. So all these next zeros, they are not necessary. They are insignificant. So you may not add them. Don't even add them. You don't need to add them. So let's now differentiate it again. Let's find the third derivative. That will be third derivative. Now will be f prime 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 to now be 3 x.
24.
Let's differentiate this part now. I'm going to get differentiation of 24 will give us what? 24x will give us what?
20. 24.
Differentiation of 14. Derivative of 14. 14 is equal
0.
to
0.
0. So it will
0.
be 24 plus 0. And 24 plus 0 will give us what? 24.
24.
So this is the third derivative. That is the third derivative. As simple as that. Do we understand that?
Yes, sir.
Okay. Let's have another example on differentiating polynomial function. Let's just have a common example. Let's just have an example. That's just how to differentiate. There's no big deal in differentiation. That is how to find the dy dx with respect to x. We now have some differentiation techniques. But let's be true with this differentiation. I want you to get it very well. I want you to understand it very well before we now move further to another level. It's not hard though. The same way we are getting this, the same way we are going to get anyone we are doing. It's not hard at all. Okay. I want to try and project a question that will be useful for us. Come in, please. Let me just try to do something here. Just a minute, please. Okay. I'm coming, please. As we are treating mathematics, we still have to we have to solving some problems to develop ourselves mathematically. So I want to get some questions. I want to project them on the screen so that we can just try it together. And this differentiation we are doing today, please, you are going to see it in your exam. You are going to see it in your TME as well. Very simple. I'm coming, please. I'm trying to get the question and project them on board. Just a minute, please. Now, no, let me do. I don't want to use this. Let me try and use this. This will be better in projecting this question. So that it will be bold and everybody will be able to see it clearly. Yeah. Okay. Now, let me start with this. I will be disappointed if you don't know the answer. I'll be disappointed. Now, I want to share this question with us. Now, from the first principle, what is the derivative of y is equal to x raised to the power n? So, what's the answer? Which of the options is correct?
nx.
Which of the options?
Nx is to the power of n minus 1.
Option A.
Nx n minus 1.
Which option
The
is
answer
correct?
is A. The answer is A. The
Correct.
answer is A.
Option
The answer is A. Multiply the coefficients with the exponent and subtract 1 from the exponent. Now, please let me project another question. I just projected one of the TME question. Okay. Okay. Yeah, I want us to do this as well. Okay. I want us to do this. Let's try this. What's the answer? The derivative of f of x is 3xk plus 6x plus 5. Find it from the first principle that we have been doing since we have been treating the first principle. So what's the answer?
Is B. B.
B.
Are you sure?
B. 6 plus 6.
Are you sure?
Yes, sir.
Are you sure?
Yes, sir.
B. B is the answer.
Correct. B is the answer. Now, what if we are given if x is equal to 2? What will now be the answer? If x is equal to 2, and you have already said B is the answer. If x is equal to 2, what will now happen? Just use 2 to replace that
12.
x. It will now be
18.
what? Eh?
18.
Eh?
It will now be
It will be what?
12.
18.
12 plus 0.
No.
12
Okay,
plus
12.
0.
It's not 12 of 0. As in, you have gotten the answer now. The
12.
correct answer. The correct answer is B. Please mute your mic. I don't know. I can hear myself back. Probably from Bright. I've muted him, so thanks. Now, this is what I'm saying. You have differentiated, you have gotten 6x plus 6. That's the correct answer. If you are now given when x is equal to 2, that simply means you are going to change this x to 2. I'm saying provided the question continues and it says when x is equal to 2, then you are going to change this x to 2. It will now be 6 times 2 plus 6.
18.
Correct. Now, let me do it on the board. 3x squared plus 6x. Let me have it. Differentiating, find the dy dx of 3x squared plus 6x plus 3, are we? Or is it 3 or 5? Let me try.
3.
3, right?
It's 5.
5.
It's plus 5.
Okay, thanks. So, plus 5. So, you have to differentiate this using the first principle, right? Now, find dy dx. Let me say, find dy dx of this function. F of x is equal to this. When x is equal to 2. So let's differentiate this thing now. Yeah, we have done it already. You said 6x plus 6. You are right. Now, differentiating this part now. That will be 3 times 2. This 3 times 2. That will give us 6x. 3 times 2, 6x. Plus, when you are differentiating 6x, it will give us automatically, the answer is 6. So that is 6. That's the answer. But the question did not stop there. The question continues by saying when x is equal to 2. That simply means once you have gotten the answer that the answer is 6x plus 6, just change this x to 2. You have gotten the answer to be 6x plus 6. Then the question continues by saying when x is equal to 2, then change this x to 2. That will be 6 into 2 plus 6. And 6 into 2, that is 6 times 2, which will give us 12 plus 6. And what is 12 plus 6? 18. So the answer is what? 18. According to the answer I projected, 6x plus 6, the option B is the correct one. No, I just continued by showing us that what if the question continues by saying when x equal to 2, so that we know how to solve that one as well. You get that?
Yes, sir.
Yes, sir.
But hello, sir.
Yes, ma'am.
But you said that the derivative of any constant is 0. If
Yes.
our answer is 18, that means it will be 0.
No, we are not differentiating 18. No, we are not. We have already differentiated this 3x squared plus 6x plus 5. We have differentiated it, and we have gotten 6x plus 6. That's our answer. If they continue by saying when x is equal to 2, that's another question entirely. They want you to change x to 2 in the answer that you have gotten. In the answer that you are about to get or you have gotten, they want you to change x to 2. You get that now?
Yes, sir.
This is the original answer. But when the question continues saying when x is equal to 2, when you have gotten the answer, then change this x, change it to 2. Do you get that?
Yes, sir. Thank you.
Yes.
All right, thank you very much. So I want to share the question with us again. Now this is the question. So the derivative of f of x is 3x squared plus 6x plus 5. from the first principle, the answer is 6x plus 6. B, option B is the correct answer. Yes, that is the correct answer. Option B is the correct answer. Now, well, if you are given when x equal to 2, that is a condition whereby you have to substitute x with 2, replace x with 2. They can say when x equal to 1, replace x with 1. They can say when x is equal to 3, replace x with 3. So the reason why I'm telling you all this is this. I'm coming. I want to prove myself. Okay? Are we together, please?
Yes, sir.
Please, let's solve this question together. What's the answer? Differentiate what you are seeing on the screen. If y is equal to sk plus 6x cubed minus 4sk plus 7x minus 2, what is the value of the y or the x at x is equal to 2? So you are to differentiate this function you are seeing. Then when you are done with the differentiation, then you replace all the x variable with 2. Please don't make mistake. They are only asking you to differentiate this function once. They are not telling you that find the second derivative, find the third derivative. No, just differentiate it once and replace that x with 2. So let's have the answer before we do the correction together. Are we still connected together? Are we solving?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. Let's solve it. We're going to do the correction together. So let's solve it. Let's try our own. Let's try it on our own. To be tried on your own, and there's a particular point that you have missed it or you don't understand it. When we do the correction together, you will now understand it. I must give you seconds, minutes like this too. So just solve it. Try it on your own. Try it on your own. Okay, I've tried it. This is what I've gotten. Okay, this is my answer. Okay. Thank God we have options. We have multiple choice. And just choose anyone you like. And I'm very sure you're familiar with the exam already. So you have to pick either 1, 2, 3. All right. I'll be waiting for someone to just tell us his or her own answer before we do the correction together.
The answer is 95. C. 95.
The answer is 95. Okay, no problem.
Yes, sir.
Let's give our people some seconds to attempt it on their own, and we do the correction together now.
The answer is 95.
The answer is 95. Mute your mic, you. Mute your mic, you. Okay. Let's do it together. Let's know if the answer is 95 or not. Let's solve it together. Okay. All right. Can I rub the board?
Yes, sir.
Yes, sir.
Can someone give me the question? The question.
4x raised to the power of 4.
4 is power 4. 4x is power 4, right?
4x raised to the... Okay, yes. 4x raised to the power of 4 plus 18x raised to the power of 3 minus
4x
8x.
is power 4. Are you confusing Mr. Ben now? I've seen the question on my system.
No, sir.
The question is x raised to power 4.
It's
Why
x raised to power 4.
uh,
X raised to power 4.
x raised to power 4? Why are you confusing Mr. Ben?
Oh, sir.
Mr. Ben, I got
Sorry.
33.
83. Okay, no problem. Let's work it together.
That's 33.
No problem. Let's work it together. I like mathematics. Anywhere you are wrong, you will see it now. And if you are not wrong, you will see it now. Yeah, this is the question. What is the value of dy dx?
95.
What is the value of dy dx at x is equal to 2? Okay, I've written the question on the board. So let's solve it together. Now, let's differentiate what we have on the board now. Let me write it here. X raised to power 4 plus 6x cubed minus 4x raised to power 2. Sorry, plus 7. Is it 72 now? 7x.
7x.
7.
7x minus 2.
7x, sorry. I wrote 72. 7x minus 2. Now, differentiating this part, it gives us 4x raised to power 3.
Raised to 3.
Am I correct?
That's first about 4 minus 1. That's 3.
Am I correct? So,
Yes.
Yes,
let's
sir.
now,
See, I beg.
let's,
When I leave only Mr. B. For people
let's,
where we say Mr. B.
let's,
When I leave only Mr. B.
let's differentiate this part as well. That'll give us 3 times 6. We give us 18 x raised to power 2. Let's differentiate this part. That'll give us 4 times 2 will give us minus 8x. It should be 2 minus 1 now. 2 minus 1 will give us 1. So we don't need to write 1 here. I told us not quite long. When you are differentiating 7x, the answer is 7. And any derivative of any constant is 0. So we don't need to write it. So we have differentiated the question we are given. They now said dy dx at x is equal to 2. That is, anywhere you can find x in this polynomial function that we just differentiated. Anywhere you can find x in this polynomial function that we just got the derivative, you have to replace that x with 2. Please, do you understand that?
Yes, sir.
Okay. All right. That will now be 4 into 2 raised to power 3
Good.
plus 18 into 2 raised to power 2 minus 8 into 2 plus 7. So don't forget, we have 2 raised to power 3 here. That will give us 2 times 2 times 2, which is 8. So we now have 4 times 8 plus 18 times 4. You know we have 2 times 2 will give us 4. So here, we still have 8 multiplied by 2 plus 7. So let's now have this as 4 times 8, which will give us 32.
So
4 times 8 will give us 32. 4 times 8 will give us 32. Plus 18 times 4 will give us 72. 8 times 2 will give us 16. Plus 7. Don't forget, 32 plus 72 will give us 104. 104. Minus 16 plus 7. Now, 104 minus 16. 104 minus 16 will give us 88. Plus this 7. 88 plus 7 will give us what? 95. Final answer.
Question, sir.
Huh?
Question.
Oh, yes. You have any question? Ask.
For I'm getting to that 7. The 2 at the back, is it not useful again?
These two, right?
Yes.
That simply means you did not join this class when we started the class. You don't join us.
You didn't send the meet in the leak on time.
No, because you did not communicate with Mr. Ben on time. You know, so let me tell you something
Go
about.
check,
No, some people are calling.
check your message, sir.
I'm declining
Check
their
your
call.
message, sir.
No, you don't understand me.
Check your message.
When I
sir.
set a
Check
class,
your message.
I understand your plight, my brother. Thank you very much, Mr. Oluwasegun Olanipekun. When I set a class to hold by 4, students will now be coming into my DM at that exact time when I'm supposed to prepare for those that they have already cooperated. Now, is it now advisable for me to be attending to new messages when some people are already there waiting for Mr. Ben to come on board and teach them? That is why I'm declining calls now, decline messages now. So they're supposed to have done this before now. It's just as if on the wedding day, you have not prepared anything. On the wedding day, well, maybe you have the wedding is to take place tomorrow. So tomorrow morning, you are running around to get a hall. You are calling. See, my phone is ringing now. See, they are calling me for the link. When I've been posting this advert since 2-3 days ago, I will have to end the call. If you want to pay me, you can't just say because you want to give me fresh payment, I will now neglect those that have paid before. No, I don't do my things that way. So I'm not insulting you, Mr. Olusegun Olanipekun, but I like getting paid before the time. I'm sorry. So anyway, let me answer your question. Let me answer your question. I'm supposed to refer you to the, because you are going to see the video after the class. But let me just teach you now. Let me tell you now. That is why you are here. Derivative of any constant is 0. This example we did here. dy dx of this 7 is 0. So anywhere you have something like this, like -2 plus 10 minus 30 plus 48, they are constant. And their dy dx is 0. So they are insignificant. Oh God, why are these people just calling me? Hello, please, can I call you back? I'm in class. I'll call you back, please. All right, thank you very much. I will not attend to any call or any message now. Okay, so the derivative of any constant is 0. Do you get that?
Yes, sir.
So that too is insignificant. So it has gone. We don't need it again. So this is the correct answer. Now, I want to teach us further. I just want us to learn more. Now, I want you to answer the question of those that are in the class. This one that we have done here, is it the first derivative or second derivative or third derivative?
First derivative.
Eh?
First derivative.
The
Thank
first,
you. The first derivative. Please don't make mistake. They did not ask that one. They did not ask that. They did not ask us that one in the question. No. I just want us to know it. Now, let's now write this question. Let's write this first derivative. Let's find the second derivative of it. For those that are just joining us, first derivative is f prime x. This is the function we are given, which is f of x. Now, to find the second derivative now, let me write it here. Let me clean this side. I want us to know it, though we have known it, but I want it to sink very well. So let's have 4x cubed plus the answer we have gotten here. Actually, this is the answer they want us to get to. Let me project the question again so that we will not be confused. We have gotten what we needed there. I just want us to learn further, as in just to learn more on it.
the power of 2 plus
Am I seeing?
36.
I'm coming. I want to project the question again for you to know that we have gotten what they asked us to do. But I just want us to still
Minus 8. That's 12x squared plus 36x minus 8.
I like people thinking ahead. That is what we call mathematics. I'm coming. Okay. I'm coming. I just want to. This is the question we did on the board. And the correct option there is 95, which is C. Option C. The correct answer there is option C, 95. Now, I'm just trying to be more advanced on this question, that what if we are to find the second derivative, third derivative, fourth derivative of this function we are given? Should we try it?
Yes.
Okay.
Yes, sir.
Thank you very much. So far, I've gotten the answer to be 95. So let me rub this now. So to find especially because of my brother, to find the second derivative now, we are going to differentiate each part again. So let's differentiate this part now. To now be 4 times 3, which is 12. X. Subtract 1 from this 3, which will give us 2. Plus 2 times 18, which will give us 36. X is power 1, which is still x. Now, the derivative of minus 8x is what?
8.
Minus 8.
Minus 8. Now, this plus 7 is what?
0.
0. Derivative of any constant is 0. So that is, we have gotten the second derivative of that one. We have gotten the second derivative of that function. Let's differentiate further. All right. So we have gotten the second derivative. So let's find the third derivative. That will now be f prime 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 x. I'm introducing this second derivative, third derivative to us because of the advanced mathematics like Math 281 in first semester 200 level, so that it will not be new to you. Though you see it also in some question in E exam, Math 102 E exam. You see it there. So that is why you see. Okay, let's differentiate this. So to find the third derivative now, 2 times 12 will give us 24 x plus derivative of 36 will give us what? 36x will give us what?
Plus 36.
36. Thank you. 36. So the derivative of any constant is 0. So we leave it that way. Then we write it there as our third derivative. So let's find the fourth derivative. F prime 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 x. Fourth derivative. Fourth. Fourth derivative. So the fourth derivative will be what?
24.
24.
24. That's all. That's the fourth derivative. Okay. So we have come to the end of today's class. Any question before we end the class today finally? Any question about differentiation? Any question? Now, I want us to know something. The first derivative, okay, I want to do something to us. And you have something like this, dy dx is the first derivative.
No question, sir. Question, sir.
I'm coming, please. The y dx, that is the first derivative. The second derivative, writing it in form of the y dx, will now be d square y over the x square. D square y over the x square. That is the second derivative. So if you see any question, you are asked to find dxy over dx square. They are telling you to find the second derivative automatically. If you see any question that find the dxy over the d square y over the x square, this is what I'm saying. Find the square y over the x square. They are automatically telling you that you should find the second derivative, or they will put it in this form. Find f prime prime x of the function that you will be given. Now, if you have to find the third derivative, it's now be d cube y over the x cube. That is d cube y over the x cube. That is short form of third derivative. Are we together, please?
Yes, sir.
Okay. Now to find the fourth derivative now, that'll be what? Someone should tell me, d raised to the power 4y over dx raised to the power 4. Do you get it now? So, let me do something. I'm sorry. We're supposed to have ended the class. Let me do something. I want us to practice this. What I've just written. Or we should suspend it in next class.
You can do it now.
I do it now.
Okay, let's do it now. We end the class there. Let me have the question like this. Don't forget we are differentiating with respect to x. So with respect to x. Let me have a question like this. Let me have find the square y of the x square of the function of f of x is equal to, let me bring it down a little bit, of f of x is equal to 2x raised to the power 3 plus 4x, let me say plus 4x squared minus 10x. This is the question now. So let's find the second square y of the x square. So we have to find the second derivative, not the first derivative. Once you see something like this square y over the x square, you have to find the second derivative. If I didn't mean they wrote dy over dx, you have to find the first derivative, first principle, using the first principle. But d square y over dx square, you have to find second derivative. So let's find the second derivative now. And you cannot find the second derivative directly without finding the first derivative. So before you can find the second derivative, find the first derivative. After that, then use it to find the second derivative and let that be your final answer. Let's go. So the first derivative now, that is dy dx now, which is also f prime x, is 6x raised to power 2 plus 8x minus 10. Do you agree that with me?
Yes, sir.
Huh?
Yes, sir. Yes, sir.
Yes,
Yes, sir.
sir.
So that is the first derivative. But that is not the answer. That's not the final answer. And that is not what they asked us to find. So we have to differentiate this again, which is f prime prime x, or d square y over d x square, which will be
12x plus 8
12x plus 8,
is
second derivative that they ask us to find final answer. Do you get that?
Yes, sir.
yes.
Okay, that'll be the end of today's class. So any other question? I will try to send assignments on the channel. If you are in our channel, you see the assignment, then just write on your own. At least to get yourself prepared, problem solving. Solve the problem.
Sir, there are many channels. Hello, sir.
Yes, so you're not on our
I
channel.
said there are many channels
Mr. Ben channel.
because I used to see link everywhere.
Eh?
I used to see the link everywhere, so I was not looking. I said I used to see your link almost everywhere, so I could not specify your own channel, like your own personal channel. Is it the now latest updates 3?
No.
Okay.
I'm coming. I will share the channel. A minute, please. So I'll be sending assignment on our channel page. But let me share the link of the channel here. Let me send it to the chat box here, so you can just join, connect from it there directly. Okay, I've sent it to the chat box. And just click it and join our channel. So, any other question before we end the class today?
Mr. Ben,
Yes, sir.
I sincerely want to appreciate you so much. Because since when I was in secondary school, I've been hearing of differentiation and integration as a very tough topic that is very difficult to comprehend. But the way you really break it for us from this foundation, I've seen it to be very easy to solve it. So thank you so much. I really appreciate.
Everybody is appreciating Mr. Ben. Very simply, very simplify the every topic for us. Even if you don't know anything about mathematics, one could be able to assimilate something. We thank you, sir.
Thank you very much. Oh, thanks to Almighty God. Thank you very much, and thanks for patronizing Mr. Ben and being part of the class. I really appreciate you all. If you are not there, Mr. Ben will not be here to be teaching now. So I really appreciate you for your time, for your dedication, and for your financial support. So,
Thanks and take.
Thank you very much.
Sir.
Yes, sir.
And there's something that I saw in that formula: quotient rule, power rule, and
quotient
what do you
rule,
call it?
power rule, chain
All this
rule, substitution rule,
and
and
product rule. Yeah.
product rule,
Then
quotient rule.
in one of those yes, in one of those this you show that and that question show that you where was some question. There's a question that came out in that this thing there. But the quiz that we attended, they failed it for us. And whereas the correct answer was the one that we know. I don't know why they failed it for us on that quiz something.
Okay. This differentiation we just started today. Next class we are dealing with product rule, quotient rule, chain rule, and partial differentiation, and implicit differentiation. So this differentiation we are now in primary 1. Next class we'll be in primary 2 of differentiation. The next class will be in primary 3. That is how we'll be doing it. But this is the first step we need to know. And once you have comprehended this, forget about the rest. You get that?
All right, sir.
Thank you very much.
Yeah.
God be with us to meet again. Have a wonderful new
Thank
week
you, sir.
ahead. Bye for now.
Thank you, sir.